Good morning, MAB Elementary. Mr. T, we're going to do some astronomy here today. Now, I'm doing astronomy for Blue Culture Group, but make sure anybody who wants to join us for these astronomy lessons is more than welcome. I might be adding some information, more than when you heard it last semester, and we're always glad to have you think about things and remind yourself of the science of astronomy, which is what we're working on. So let's start. Yesterday, if you looked at our lesson, you learned about our neighbor in the rocky planets, Mars. Well, today we're going to work on our home planet, the Earth, and our satellite circling us, the Moon. So let's start with the Earth. About 4,600 million years ago, that's 4.6 billion years ago, in a spinning nebula around our star. Our star was forming. Remember, it was a third generation star. We go back to the Big Bang 13.6 billion years ago. So much had happened. We're talking coming forward about 9 billion years since the Big Bang. And so we have this nebula where the solar system is forming around this glowing and accreting nitrogen star, this third generation star that had come after supernova had created this nebula of gases and rock and elements that began to form into our solar system. So the Earth was one of the rocky inner planets in this spinning disk inside the nebula, spinning around our star, which had just gone into a nuclear furnace and was the energy from which was forcing the rocky planets and the gaseous giants to form as our planet system. Well, the infant Earth, its gravity force, because it had a lot of mass, was attracting dust and gases and larger lumps from the nebula. These would be asteroids and meteoroids and comets that were circulating around. So there was lots of matter to accrete, to be absorbed by in colliding with the Earth. And the collisions into this forming sphere of the Earth generated friction. Remember, rub your hands together real fast. You feel the heat that generates? Well, all of these colliding objects into the Earth's mass, a ball of material, created a lot of heat. The Earth began to heat up into a molten ball of matter. It was kind of viscous, kind of, if you think of like peanut butter. And the colliding objects became part of the Earth, and the Earth grew and grew and grew in size. About 1 million years after this process started, the Earth had reached about 1/2 of its present size. But it took 90 million years more of collisions to become its present size because the growth of its size began to slow down because the amount of materials left around the Earth that it could accrete and attract with its gravity field became less and less. So after the Earth reached its present size, and there were many fewer collisions from objects coming in from outer space, the surface of Earth began to cool, and the elements began to sort into layers based on their mass. So the heavier elements like iron and nickel began to sink down into the mantle and ultimately into the core of the Earth, and the lighter ones like carbon began to rise to the surface, to the crust of the Earth, and form the Earth's crust as we know it, as it cooled over millions of years. You guys are going to explore the formation of the Earth and the layering of the Earth all the way down to its core with Mr. Smith in geology, so I'm not going to go into that in astronomy. In astronomy, we're more interested in what's going on outside the Earth's crust, not inside it, and I'll leave that to Mr. Smith, who's an expert on geology of the Earth. So there'll be pictures following this of the Earth and various ideas about it, and I'll provide some details in the comments on the pictures like I always do, So I urge you to review those and continue to deepen your knowledge of our planet Earth, our home planet. So let's go on to our nearest neighbor, the moon. I've got a bunch of information on the moon, so let me just give you that now, and so you'll know the science. And again, I have a great poster. We've taken great pictures of the moon. We've mapped the entire moon in a lot of detail. So I'll be referring to various objects on the moon and places on the moon and structures on the moon's surface that you will be able to see from the poster that I put up on the Facebook page. You'll need to make it larger so you can see these things, but it would be great if you could put that up and look at it while I'm talking or after I'm finished the scientific information. So here you go on our nearest neighbor, our moon. It's the largest satellite among the rocky planets. No one else has a moon as big as ours. It's the only other world. This is really something to think about. It's the only other world that humans have visited. And the Apollo program put U.S. astronauts on the moon several times, many times. And you will see some pictures, I think, of what the astronauts saw when they arrived on the moon. It's heavily cratered. One of the biggest craters is Copernicus, and it's 57 miles across. And those craters, remember, were caused in the early formation of the moon when it was accreting and molten like the Earth, when it was impacted by asteroids and meteoroids and formed these impact craters all over the moon. The moon is a non-luminous object. That means it only reflects sunlight. It looks really bright in the sky, and if you saw that full moon the other night, it was magnificent. But the moon doesn't generate any light itself. It's that's a prefix that means not luminous. It doesn't have its own light. And its illuminated area changes daily with the phases of the moon. And if you go out and see the moon tonight, you'll see whatever stage it's in. I guess it's probably about a half moon right now, and it'll go to a quarter moon, and it'll disappear altogether, and then it'll come back, and it'll begin to show you more of itself because the Earth is blocking the sun from reflecting on the moon. The Earth spins only one Earth orbit due to the slowing effect of the powerful Earth's gravity. Therefore, we see the same face of the moon all the time. There's the dark side of the moon, which we can't see, and there's the front of the moon, the light side, that we do see because it spins at the same time as the Earth orbit spins. So we're looking at the same place on the moon all the time. The moon's gravity causes the ocean tides. So when the moon is close to North America, its gravity is pulling the sea levels up, and so we have the high tides. And then when the Earth spins and the moon is on the other side of the Earth, then our tides are not affected by its gravity pull, and the levels of the ocean go down. So the tides of the ocean, rising and falling, is moving around the Earth because of the gravity pull of the moon. In its orbit around the moon, the closest the moon ever gets to the Earth is 363,000 kilometers. That's about 50,000 miles. Its mass, the moon is very small. Its mass is 1/100th that of the Earth. 1/100th in your decimal fractions. The gravity on the Earth, because it's a small object, and remember, objects' gravity force depends upon the amount of mass they have. And so the gravity on the moon is only 17/100ths, less than 20% of the Earth's gravity. So Mr. T, for example, I would weigh 25 pounds on the moon. Because remember, weight is the effect of gravity on your mass. My mass would be the same, 150 pounds on Earth, but I'd only weigh about 25 pounds on the moon. That's why when the astronauts first went up there, they would take a step and they kind of bounced along when they walked, because the gravity force on the moon is only 1/5 of that on the Earth. So, how do astronauts and astrophysicists believe that the moon formed? Well, we've developed some new science on this in not in the very distant past. And here's what we now know: about 4 billion years ago, when there was still the Earth was a spinning ball of molten lava, this viscous peanut butter like. The Earth was struck by a huge asteroid, and it caused a massive amount of material. You know, if you throw a rock into a pond, you see a big splash of water coming out, and the bigger the rock, the bigger the splash. Well, something like that happened, and a huge asteroid smashed into the molten Earth, and a massive amount of materials flew out into space. And it formed rings around the Earth, just like the rings around Saturn. And in a very short time, and scientists think just about 10 years, the material in the rings adhered by the force of gravity. So that material out there in those rings began to accrete, and the bigger objects, gravity pulled in more and more. And finally, there was just one huge mass of materials orbiting around the Earth, and that formed into a sphere based on the pull of gravity, and that was our moon. So our astronauts orbited the moon before they landed on it, and we sent satellites up to orbit the moon, and that took pictures. They were able to take pictures, and that's how we mapped the whole moon, and that's the poster you'll see. The near side, the side that we see, the dark surface that are on there, and you'll see from the poster, they call them the seas, but they're not really seas. They're just large craters, and because they're deep, they're shadowy from the sunlight that sun shines on the moon. And then the highlands are the brighter areas, kind of plateaus where the sun is brighter. The far side of the moon is mostly bright highlands with many craters that were caused by the meteorite bombardments. I spoke to you before about our astronauts landing on the moon, so here's a little bit of details. And guys, I can't wait till we can go back to the Space Museum when it opens up, because there's some fantastic exhibits on the lunar landers, the Apollo astronauts, and that whole space program that took the Americans to the moon, took our people to the moon. And from 1960 to the 1970s, John F. Kennedy was the president. And he challenged the Russians, because the Russians at the time were our competitors in science, and they were working on their space rockets and space exploration as well. And John Kennedy made a famous speech in 1960, and he said, and this was after the Russians had launched the first man-made satellite to orbit the Earth, and it was called Sputnik. And when Sputnik went up, the American people said, whoa, the Russians are way ahead of us in terms of their space science and space exploration. And John Kennedy made a speech. He was a great president. He said, we're going to get to the moon first. And on Apollo 9, it took a bunch of practices to go up to the moon, to orbit the moon. And finally, 9 Apollo crafts went to the moon. 6 of them landed, and 12 astronauts. There's only 12 people in the history of the human race that have either walked or rode a rover. At one point in time, they had like a Jeep up there that they could ride around the moon. And like I say, all that moon history of exploration of the moon is on great detail at the Space Museum, and we're sure to go there again sometime in the near future. So this is Mr. T with Astronomy, study of our formation of our home planet, the Earth, and our moon. I hope you found it interesting, and there'll be pictures to follow. Don't forget, your follow-up work at this point in astronomy is to collect Who Am I research reports on each one of the planets. You want to make yourself into a cool booklet, put a cover on it, put your name on it, and it'll be your planet research encyclopedia. That's a cool thing that you'll have. and you'll be able to remember all of the interesting astronomy science facts that we've been discussing here. So this is Mr. T out. Hope you're enjoying astronomy.